what we are demonstrating here in our innovation workshop here is the single RAN. The single RAN is our new multi-radio platform with the base station. We have a demonstration and a product right here. This is a single box compact multi-station which can multi-radio base station which can support 2G, 3G and 4G flexibly on the same box. The product supports multiple technologies, multiple RF variants, and in a very, very small footprint and compact way. Going forward, the product has two different variants. You could have a system module which is the same size as what is shown here, and you could have an RF variant which is adjoining which is same size as the system module. This can be deployed flexibly on walls, on poles, on tower tops, close to the antenna, almost a zero footprint solution. And the other variant could be a remote radio head solution, again which can be deployed on top of the antennas in a very, very compact and zero footprint. Not only does it give zero footprint, but it also enables a very, very optimized energy consumption. So we are dealing with all these aspects in the radio evolution products that we are going to be deploying in the future. This demo is about what we demonstrated recently in our Barcelona demonstration in the Mobile World Congress, which is something coming out of what we call the FutureWorks. The FutureWorks is our portfolio which we are bringing to the table, showing as coming from our technology and innovation team, whereby we are saying that what are the various advancements in technology which are going to happen over a period of time. And one of the hot topics being discussed is about 5G. Now what is 5G? 5G is an evolution of the existing 2G, 1G to 2G to 3G to 4G technologies. It is something which is not completely disruptive. It is ability to be able to use networks in the future with the minimum latency possible, exploring frequency variants and bands which are available in higher bands of frequency in a more optimal way for the use of mobility as a solution. So dealing with the entire spurt of data which is happening on next generation media requirements, real-time control, reducing the latency. 5G enables us to give the option of dealing with the future where this 10,000 times more traffic requirement will become a reality, and we need to have a view as well as approach to deal with this in the future. So, as we said, the architecture of 5G will evolve from the existing architectures of 2G, 3G, 4G. It will harmonize all these existing technology variants and deal with the future where larger spectrum availability in higher bands of utilization, such as the bands which are beyond the 3 gigahertz spectrum going up to 90 gigahertz of spectrum, are going to be optimally in the future be used for providing services for mobility. The millimeter wave, the centimeter wave, huge amount of spectrum available in the in the world across all operators, not being utilized optimally for mobility, can be used in a more efficient way.
Starts
we are demonstrating our future small cell solution. There is a live or a prototype available with us of an outdoor small cell. As you can see, there are these three different variants of the small cells that we are showing here. One with the 5 kg variant, micro and pico. The other one, which is the 8 kg variant, which can give 2 into 1 watt down to 2 into 250 milliwatt of power. It has also got integrated Wi-Fi enabled inside the same product. It comes from the same family of our conventional multi-radio and flexi platform, and uses the same software to take them into smaller configurations of small cell. And the third variant we are showing is the indoor pico variant of the small cell, which is again integrated with Wi-Fi, comes as a 3 liter or a 3 kg variant, much smaller in size, almost the size of a Wi-Fi router, and can be optimally utilized in order to look at the future heterogeneous network evolution, which is going to be a reality. Some of these small cells, as you can see from here, have the same capacities as the micro in a much smaller footprint, use the technology innovation and edges that we already have in our macro base stations like smart scheduler, have the same O&M, same service operation, same self-optimizing features which are there in the macro sites, and of course support security in exactly the same way that they're dealt with in the macro sites. This is an example of how small cells potentially can get deployed in a live network where there is need for capacity. And these are deployment examples of small cells, how it can be deployed in an aggregated mode or a standalone mode. So a number of small cells, as you can see here, are integrated together into an aggregator, which then can be connected to the transmission media or backhaul to take all the traffic out of their zone or building.
Yeah.
This is the Nokia's predictive operations demonstration that we recently launched in Barcelona. Nokia being the only vendor who has actually tried to do something innovative like this. What we are trying to do here, or what we've been able to achieve here, is use the data available with the networks. So as you can see over here, that in the last 2 years itself, the amount of data that has been created or by the networks is more data than what was created in the last 50 years. And what we are trying to do is use this big data analysis, do study and analysis of this data, and try to predict the future requirements of how the networks is going to behave. So predicting the behavior of the network in advance up to 24 hours to 48 hours before, in order to avoid a problem before it happens, thereby increasing service levels by almost 15%. Now, this is a demo that we have where in a conventional network, if there is no predictive operations, if there is a problem which happens, it results in an outage, and for the time that the outage happens, there is a complete downtime. Now what we are trying to do in this predictive analysis is trying to predict before the problem happens, 24 hours to 48 hours before, looking at various KPI triggers, analyzing them and seeing that potentially there could be a problem after some time, fixing that problem after it is analyzed, so that we avoid happening any of these outages in the system. So it is something like healing the network before actually the issue happens. So in a conventional operator, we monitor various KPIs with certain thresholds. So there are hundreds of KPIs that are monitored in the network with various KPIs. Now what we are trying to do with predictive operations is we are monitoring these KPIs with much lesser thresholds, trying to analyze any behavior in the network KPIs which can trigger a problem in the future by looking at previous analysis of whenever that problem happened, did it have any impact on any KPI beforehand. And by using this kind of data analysis, predict if there is potentially a problem with the 95% accuracy and then fix it before the problem happens.